I'm Alessandro Pompili and I will present the work A Procedure for Measuring the Kinematics of the Foot and Ankle Complex through Weight-Bearing CT. The work presented here is a part of a larger study, whose goal is the accurate and systematic description of the kinematics of all the bones of the foot. A possible solution to describe the kinematics with the max accuracy is through a series of static CT scans. The aim of the work is to define and to validate a procedure that is fast and accurate for the kinematics reconstruction from CT scans. The foot is scanned in weight-bearing CT in 15 different configurations, varying dorsiplantar flexion and prone supination angle among wooden wedges to map all range of the foot motion. The kinematics reconstruction includes semi-automatic segmentation and automatic registration. The segmentation was carried out in the free software MITK. Firstly, bones are identified by a single bound threshold whose low bound is manually selected to minimize the overlap among bones. After this operation, if necessary, the bones have to separate manually. Then each bone segmentation is completed by two morphological operations, closing and filling up. After the segmentation, we defined anatomical reference systems for each bone. We performed bone registration by an automatic algorithm based on iterative closest point defined in a MATLAB routine from the neutral to the specific scan to define bone kinematics. To test the quality of segmentation, we tested 3 feet calculating die score comparing with manual segmentation. In the table, we can see the results of die score analysis. The mean value is over 95%. In Table 2, we can see the results of accuracy test of overall procedure. To assess the accuracy, bob motion is simulated with a set of 5 synthetic scans obtained by applying 5 rigid rototranslation to the die confiles of the neutral position. These scans are processed with the procedure and the computed kinematics is compared with imposed motion. The limit of the procedure are that the procedure is not fully automatic, but the operator involves only the manual separation of the bones. In addition, the procedure high invasiveness limits the use in vivo studies. In conclusion, we presented a procedure able to reconstruct kinematics of whole bones of the foot with an accuracy of less than 0.5 degrees and 0.1 millimeters. Thank you for your attention.